Good afternoon, dear students. We will see the topic of finite state machines, VHDL implementation of finite state machines. Before going to VHDL implementation of finite state machines, let us understand what is finite state machine. Now, as the name indicates, finite state machine, it has got the limited number of states. For example, if we want to design a finite state machine, that is FSM, for detecting the sequence of 111, let us say, when the serial input X is equal to 111, then the output Z is equal to 1. Now, finite state machine is of two types. One is called as Moore finite state machine, and second one is called as Mealy finite state machine. Now, in case of Moore finite state machine, the output Z is function of only state of the machine, and in case of Mealy FSM, the output Z is a function of state and input X. Okay. So, we will draw the state diagram for Moore machine, Moore sequential machine, state diagram for Moore FSM. Okay. Let us consider, let input X is equal to all zeros before we start the circuit. Before we start the circuit. Okay. So, we will have a state represented by a circle. Let us say that this is state A, and our input X we have considered to be all zeros. Okay. So, the machine will continue in state A, as long as our serial input X is equal to 0. The machine will advance further only when X is equal to 1. Let us say this is our first one, and in state A output is 0. Now, the machine will go to state B with output 0, as we have got only first input X equal to 1. The machine will advance to next state C with output 0 for another X equal to 1. When we get third time X equal to 1, now our sequence is getting complete. We want 3 ones to be detected. Here this is our third one. So, machine will go to state D, and here in D state output will be 1. It will remain in state D as long as X continues to be 1. Now, in every state we should have 2 arrows leaving the state, because you have got one input X. So, 2 to the power 1 is 2. Okay. Now, in state B we have taken X equal to 1, where the machine will go for X equal to 0. When we get X equal to 0, our sequence is broken. So, machine will go to state A, okay, for X equal to 0, In state C, if we have x equal to 0, it will go to state A, and in state A, output will be 0. Similarly, in state D, if we get 0, machine will go to A with output 0. So this is the state diagram for Moore sequential machine. Now let us prepare the state table. Let us prepare the state table. Let us prepare the state table. In state table, we write present state, PS, then we write next state, NS. Now next state corresponds to one value of x equal to 0 and another value of x equal to 1. So we will have here two columns in the next state, one for x equal to 0, another for x equal to 1. Now here it is next state oblique output. So we will write here next state oblique output. Okay, we will write here output Z. We will write here output Z. Okay. Now let us complete the state table. So we have got here 4 states A, B, C, D. So we will write 4 states A, B, C and D. Okay. Now from the state diagram, we will identify the next states where the machine is going for x equal to 0 and for x equal to 1. Now we find that in A state, if we get 0, the next state is A. So we'll write here A, and for x equal to 1, it is advancing to state B. So we'll write B here. Now when the state is B, when the present state is B, for x equal to 0, machine is going to state A. So we'll write here state A. For x equal to 1, it is going to state C. So we'll write C here. In C state, if we get x equal to 1, machine is going to state D. For x equal to 1, it is going to D. For x equal to 0, it is returning back to A. Now when the present state is D, when the x equal to 1, it is staying there itself. And for x equal to 1, it is going to A. Now in Moore's machine, output is function of only state. So in state A, B, C, D, the outputs are already written. In states A, B, C, the output is 0. So we'll write here 0. And in state D, output is 1. Now here we find that, let us check whether the next states are same or different for the present states. Here next state is AB, there is no AB here. When the present state is B, next states are AC, there is no AC. In state C, the next state is AD. In D also next state is AD, but the outputs are different here. So this state diagram is having minimum number of rows, or there is no possible of reduction. Now the next state in the design is state assignment. State assignment. There are 4 states A, B, C, D. So for 4 states, we require 2 state variables. We require 2 state variables. Let us say the state variables are S1 and S0. Okay. So we'll write present state. Let us say instead of S1 S0, we will write Q1 Q0. Okay. Now Q1 Q0. So let state A, present state A, have Q1 Q0 representation as 0 0, then state B as 0 1, state C as 1 0, state D as 1 1. Right? Now we will write here state assignment table. State assignment table. I hope you are following it. Now we'll write here present state. State variables are Q1, Q0. So A, B, C, D. A is our 0 0, B is 0 1, C is 1 0, and D is 1 1. We'll write here next state. Now next state, there are two next states, one for x equal to 0 and another for x equal to 1. X equal to 0 and for x equal to 1. So we find that for x equal to 0, the next states are A. A is represented by 0 0. So we'll write here Q1 Q0 as 0 0, 0 0, 0 0, 0 0. Okay. Right. And for x equal to 1, the next states will be, here it is B. B is represented by 0 1, so we'll write 0 1. C, next state is C for B. C is written as 1 0, it will be 1 0. Here next state is DD. DD is 1 1. And output Z will write output Z. Output Z is 0 0 0 1. So we'll write 0 0 0 1. Now let us consider we are using JK flip-flop for the design. Let us select JK master slow flip-flop for the design. For the design, okay. So the excitation table for JK flip-flop, excitation table for JK flip-flop is like this. It is QT to QT plus 1, the value of JK. There are 4 possible values of output transition, 0 to 0, 0 to 1, 1 to 0 and 1 to 1. Okay. For 0 to 0, J is 0, K is don't care. 0 to 1, it is 1 don't care. 1 to 0, it is don't care 1, and 1 to 1, it is don't care 0. Okay. So using this transition, let us have the state transition table. Okay. So I hope everyone has noted this diagram. let us draw here state transition table. State transition table. So again we will have PS Q1 Q0 0 0 0 1 1 1 1 0, right. Now then we will have next state, one for x equal to 0, another for x equal to 1. So Q1 Q0 Q1 Q0, it will be all 0 0 here. Here it will be, it is 0 1 1 0 1 1 1 1. Okay, and let us have the excitation values of JK flip-flop. Excitation table. We will require here 2 flip-flops. So JK, okay. So here we will write the values of JK inputs. So we will write for x equal to 0 and for x equal to 1. Here it is J1 K1 J0 K0, here J1 K1 J0 K0. So now we find that here 0 to 0 transition is there, 0 don't care, 0 to 1 1 don't care, then it is 0 to 1 we are writing for x equal to 0, so we will see this Q1 to Q1, 0 to 0 0 don't care, 0 to 0 0 don't care, 1 to 0 don't care 1, sorry 1 to 1 it is don't care 0, 1 to 0 don't care 1. Now for this x equal to 0, Q0 to Q0 transition, 0 to 0 0 don't care, 1 to 0 don't care 1, 1 to 0 don't care 1, 0 to 0 don't care 0, 0 to 0 0 to 0 0 don't care. Okay. Now for x equal to 1 we will see this transition, 0 to 0 0 don't care, 0 to 1 1 don't care, 1 to 1 don't care 0, 1 to 1 don't care 0. Okay. Now for J0 K0, 0 to 1 1 don't care, 1 to 0 don't care 1, 1 to 1 don't care 0, 0 to 1 1 don't care. Like this will proceed. Now output Z, Z is 0 0 0 and 1. Now the next step is we will find the excitation values of JK inputs. Okay. So we will find excitation values for JK inputs. Let us first find the equation for J1 K1. Okay. Now J1 K1, it is in terms of input x. We find that the excitation values, they are dependent on q1 and q0 and value of x. Okay. So we will have three variable K-map like this. Let us have x here and q1, q0 here. So 2-bit gray code will write here and 1-bit gray code here. For x equal to 0, what is J1? J1 is 0, 0, don't care 1. No, 0, 0, don't care, don't care. So 0, 0, don't care, don't care. For x equal to 1, it is 0, 1, don't care, don't care. 0, 1, don't care, don't care. And this for J1. And let us say for K1, what we have here, K1, let us have x here, q1, q0 here. Now the value of K1, don't care 0, 1. It is K1, don't care 0, 1. And here K1 is don't care, no, K1. K1 is don't care 0, 0. Okay. Now let us find the equations. This one will combine with this. So J1 is our Q0x and K1 is here. K1 is here, Q0 bar x bar. Now let us find the equation for J0 K0. Okay, J0 K0. Okay, I hope everyone is getting right. We are finding the excitation values for J0 and K0. So here Q1 Q0 x, Q1 Q0 x, 0 0 0 1 1 1 1 0, 0 0 0 1 1 1 1 0, 0 1. Now let us fill the values of J0 K0 here. It is box number 0, 0, don't care. Box number 1, don't care 1. Box number 3, don't care 1. And it is 0, don't care. Now here for x equal to 1, it is 1, don't care 1, don't care 0, and it is 1, don't care. It is A, B, C, D. Okay. A, B, C, D. C is our 1, 0, D is that. Okay. Let us change over here the state assignment. We have done like this. C is our 1, 1 and this is a 1, 0. Okay, no problem. Now C is 1, 1. Okay, there is, okay, ठीक है. Now there is some change over here. This is 1, 0, this is 1, 1. Okay, so it is 1, 2, 0, J1 K1, 1, 2, 0, don't care 1. and 1 to 0, again it is don't care 1, and for x equal to 1, 1 to 1 don't care 0, 1 to 1 don't care, it is okay. Now for x equal to 1, for x equal to 1, 0 0, 0 don't care, 0 1, 1 don't care, 1 to 0, 1 to 1 don't care 0, 1 to 1 don't care 0, 1 to 1, okay, 1 to 1 don't care 0, and 1 to 1 don't care 0, correct, ठीक है, okay. And here in Q0, in case of here it will be 0 to 0, 0 don't care, 1 don't care 1, then 0 to 1, 0 to 1, 1 don't care, and for 1 to 1 don't care 0, okay. Here for x equal to 1, q0 to q0, it is 0 to 0, 0 don't care, 1 to 0 don't care 1, 0 to 0, 0 to 0, 0 don't care, and 1 to 0 don't care 1. Okay, and here it is 0 to 1, 1 don't care, 0 to 0, 0 don't care, and 1 to 1, 1 to 1 don't care 0, and 1 to 1 again don't care 0. Okay. So let us fill the values over here. It is x equal to 0. Let us find the equations for these. So we find that here for x equal to 0, j1, k1, it is 0 don't care, 0 don't care 1, it is 1 here, and don't care 1, okay. And for x equal to 1, 0 don't care, 1 don't care 0, and again don't care 0, right. The equations are same. It is coming over here q0 x, and this is coming as q0 bar x bar, okay. There is no change in the equation. Now let us find these values. j0, 0 don't care 1, then 0 don't care and don't care 1, and here 1 don't care, 0 don't care, okay. Then don't care 0 and don't care 0, okay. So here we are having grouping like this. So this is coming out to be q0 bar x, and k0 is coming out to be equal to x bar, okay. Now the next step is draw the circuit diagram that we can draw, okay.